Alright, trying to find the volume using the shell method here. It says given the region contained by y equals 3 over 2 times the square root of x, then y equals 0, x equals 1, x equals 4. Find the volume when it's rotated around the y-axis. So, y-axis means our volume formula will be 2 pi from A to B of the radius times the height dx when we go around the y-axis. Okay, so let's kind of draw this out. We might be scared of a little bit of it, so let's see here. It says we're going to have x is 1 and 4, so let's kind of tick over at least that far. 1, 2, 3, 4. So we know that whatever we draw is going to be contained between these two guys. 1 for x and 4 for x. And also y equals 0. So I'm guessing we don't need the bottom of this now that I've looked at it. So y equals 0 kind of cuts us off down here at the x-axis. So we definitely got something in here. So we probably don't really know what 3 over 2 square roots of x looks like very well. But we do know it's going to go from 1 to 4. And the square root is going to be a positive, so it will never go below that x-axis. So let's see here. If I plug in 1 for the x equals 1 over here, I would get 3 halves. So here's 1. So here's 1, here's 2. So 3 halves would be somewhere in here. And if I plug in 4, I would get 3/4. So it's getting smaller. So I think it looks something like a curve like this. But I know I have the 2 correct points, and I know it's in the first quadrant and bound between here. So without getting any more exact, I think we're okay by just looking at this region, and we just said it was going to go around the x-axis. So let's see here. We need everything in terms of, we're going around the y-axis, sorry. Getting too excited. So let's see here. We're going to go around the y-axis. So everything needs to be in terms of x. So let's see here. We got the volume of 2 pi. And in terms of x, it's going to go from 1 to 4. The radius will be x. And the height will be the actual function here. The 3 halves over square root of x. So 3 over 2 square roots of x dx. So here the x is the radius and the 3 over 2 square roots of x is the height. So let's clean that up a little bit before we actually do the integration. And a little tip here, we can actually pull, well, it doesn't matter. We'll just keep going the way it is. We'll have 2 pi from 1 to 4. And let's say we got 3 halves, and then we got x, and we'll have x to the negative 1/2, so it'll just be x to the 1/2 dx. So I think this is right. Comes up as a negative 1/2. Everything looks good. So let's see here. The integration will be 2 pi, and then we will have the 3 halves. And then we will have x to the 3 halves, and we divide by 3 halves, that'll be multiplying by 2/3. And that will go from 1 to 4. So it looks like the 3 halves and the 2/3 will knock each other out. And the main thing I will have will be 2 pi x to the 3 halves from 1 to 4. Okay. So let's plug those in and see what we get. Let x equal 4. So what do we get here? If we plug in 4, we'll have 2 pi times 4 to the 3 halves. That is the square root of 4, which is 2. And then it's cubed, so it's 8. So that'll be 2 pi times 8. And let's see, that'll be minus, and we'll let x equal 1. So that'll be 2 pi times 1. So it looks like we got 16 pi minus 2 pi, so 14 pi. As soon as you start getting far enough away from the axis, it starts to get to be a little bit bigger number. Okay, So I think that's right. We'll pause it and look at it, and if good, I'll just end it here.